All right, today we're going to pull back the curtain and go inside the modern software factory. We're going to see how a simple idea, really just lines of code, gets automatically transformed into the amazing applications we use every single day. So, how does it all actually work? Let's dive in. You know, it can really feel like magic, right? A developer writes some code, pushes a button, and boom, a website just appears online. But it's not magic. It's a highly engineered, really elegant process. So what is really happening between that keyboard and your screen? To really wrap our heads around this, we're going to use a powerful metaphor. We are going to build our very own software factory, right from the ground up, using the blueprints from a real-world project.
Okay, so just like any real factory, you can't just start building. You need a blueprint. Before we can even think about production, we have to get familiar with the core machinery that makes the whole thing run.
So the absolute heart of our factory is something called a CI/CD pipeline. Just think of it as the main assembly line. It's a completely automated system designed to take the raw materials, that's the code, and move it through every single stage of production until a finished, working product rolls out the other end with basically zero human hands touching it along the way. Okay, so let's map this factory idea directly to the real tech. Our raw material? That's the source code from a project called eShop on Web. The packaging we'll use is something called a Docker container, which basically puts our application into a standardized, shippable box. The factory building itself? That's going to be the Microsoft Azure Cloud. And the robotic arms running the whole assembly line? Those are the Azure DevOps Pipelines. All right, we've got our blueprint. It is time to lay the foundation. First things first, we need to set up the factory floor. This is the initial one-time setup that gets everything ready for production to start.
And you know what? This part is actually pretty simple. First, over in Azure DevOps, we create a new project. Think of this like fencing off the land for our factory. Then we import the source code from GitHub. This is like the first truck of raw materials pulling up to the loading dock, ready to be fed into the assembly line.
So, the factory floor is prepped, our materials are on site. Now we can fire up the first half of our assembly line. This whole section is called continuous integration, or CI for short, and its entire job is to build and package our product.
Now this is super important to get. Our assembly line is really a tale of two halves. The first half, the one we're looking at now, is continuous integration, or CI. Think of this as all the internal factory work, taking the raw code, building it, testing it, and then packaging it into that standard Docker container. It all ends with that finished package sitting safely in our warehouse. The second half, continuous delivery, well, that handles everything after that, getting the product from the warehouse to the customer's hands. So let's watch this first part of the assembly line in action. The moment a developer commits new code, the pipeline wakes up and automatically builds our warehouse, a secure private storage space called an Azure Container Registry. Then it gets to work building the code into that standardized Docker package. It slaps a label on it, latest, and a unique ID for tracking. And finally, it pushes that finished package into the warehouse, ready for delivery.
And just like that, phase one is done. We haven't actually shipped anything to the public yet, but what we do have is a perfect, version-controlled, standardized unit of our software, sitting securely in our private warehouse, ready to go at a moment's notice. Okay, now for the really cool part. We've got a product sitting in the warehouse. How do we get it out to the world? Well, for that, we turn on the second half of our factory, the Automated Delivery Fleet, also known as Continuous Delivery, or CD. And just like the first half, this delivery system is completely hands-off. First, the pipeline builds our digital storefront. This is the live website where users will actually see our product. Next, it gives that storefront a special key, granting it permission to pull packages from our warehouse. And with that access, the storefront automatically goes and grabs the package labeled latest and puts it on the digital shelf for everyone to use. So, after all that automation, all that building, packaging, and deploying, what do we actually have to show for it? We have a live, working application.
The machinery we set up is now fully operational. The assembly line took the code, the delivery fleet took the package, and now the product is on the shelf. The process is complete.
And this quote right here from the source material, it just nails it. From a simple folder of code to a live web application, we've walked through the entire automated journey. And this isn't some fantasy model. It is exactly how modern software is built and delivered all around the world, every single day.
So why go through all this trouble? Why build this whole factory? Well, it boils down to 4 huge advantages. First, speed. You can go from an idea to a live feature in minutes, not months.
Second, reliability. Robots don't make typos. Automation just crushes the human errors that can cause outages. Third, consistency. Every single update is built and deployed using the exact same proof and process. And finally, scalability. Releasing a new version is as easy as just feeding new raw materials into our already running factory.
When you think about it, what we've really done is transform software development from a slow, manual craft into a high-speed industrial process. And that leaves us with a pretty fascinating final thought. Now that we have these incredible automated factories, what other amazing things are we going to build with them?
In this section of this lab of Azure DevOps, we are going to do deploy Docker containers to Azure App Service web apps. And the task involved or objective of this lab is build a custom Docker image by using a Microsoft hosted Linux agent, push an image to Azure Container Registry or ACR, deploy a Docker image as a container to Azure App Service by using Azure DevOps. I will pass this Microsoft Learn GitHub link so that you can follow this lab. So let's start with the lab now. The very first thing that I'm going to do is connecting to Azure DevOps portal. Here I have connected to Azure DevOps portal on the project here. And then into the project page, select project settings. From there now, if you see here under pipeline, there is a service connection. We are going to set up a service connection. So select that service connection button and then click on create service connection. Select on Azure Resource Manager. Click next. Make sure app registration value credential subscription. Under subscription, select subscription. Select resource group. Then give a service connection name. And make sure that grant access permissions to all pipeline is disabled. Then click save button. So this is a prerequisite steps to continuous with the Azure Labs here. So when that service connection is done, we are going to add users role to service connections. So for that, let in the search options select a type subscription. And here you see the subscription that ignite there. This one, select that subscription. Close this here. You can see that access control. Select that access control. And from here, you see the drop down list. Select the drop down and click on add role assignment. And here is the different options available like role, members, assignment type, and others options. And there are functions. This is the job function roles and privilege administrator roles. So select that privilege administrator roles. And here you see that the LOD owner. Which actually this role grants all full access to manage all resources, including the ability to assign roles in Azure RBAC also, rollback access control. So select that one and click next. Now here it's coming the members option. So select that members, and from here uh, select the members name. In this case, this is user, or you can get that one actually which you copied uh, from here, this display name for this member. So select that one here. So this is the member ID, and then click select. Now next is conditions, so click next. Here different options for this. Here you can select assign, allow users to assign all roles highly privileged one. Select this option, that user, what user can do, then select next, and then you can select review and assign. So adding role assignment in progress, and that has been done. You can see that user's role, you can see that has been assigned. So now we'll deploy Docker containers to Azure App Service web apps. So for that, let me go to another like second console here. Let me go to Azure DevOps straight to this console. That will be easier. Select the project here. Select repos. Then under files, you can see that there's an option import a repository. Click on import. Paste the provided that repository URL and select import. So it's importing that repository. So now let's go to branches. There is only one branch right now. Select branches and make that main branch as a default branch. So select this ellipse button and set as default branch. When that is done, we are going to import and run the continuous integration pipeline. So for that, let's go to pipeline section here, pipelines, and select the pipelines. So create a new pipeline. So create pipeline. See all the options. So create pipeline. And here we're going to use Azure repos gate. Select that is shop on web directory. And here existing Azure pipeline YAML file. And here give the path. So you can instead copy that file, otherwise you can select. You can go and select from here also. Then click on continue. So here we need to update that subscription ID, resource group, and location. So subscription ID, Azure Service Connection, we created. This is your subscription ID. Resource group. And the location here. Um, this is doing a build. Settings, task is Docker. So mainly what it is doing here, it's downloaded the repository files that will be used in the task like resource manager template deployment. And then the PowerShell retrieve the ACL login server value from the previous task output and create a new parameter. Um, Arc login servers. Then after that, build the Docker image and create two logs. One is latest and another one is current build ID. Now here is that save and run. So select that one, save and run. Give the comment for now default is fine. So commit directly to the copilot at Kubernetes Terraform support branch. So no need to change here. We are not doing any new branch. Just the branch itself for now. Save and run. From the execution page, you can see the logs, you can see the jobs, which jobs is currently running. Open a new tab. So here it's giving a message like this pipeline needs permissions to access. So click view. And then here is the permission. So give the permission here, permit. And then permit access just to confirming, select permit. Now job has been started now. So let's come back when deployment is complete. So now build is complete. Go back to pipeline and rename that pipeline. Click on save button. Now open a tab for Azure portal now. And search string, search for container registry. There is a app container registry. Or let me go back to resource group and find there. So this is the resource group because it should get under here. You can see that container registry is here. Now, after that registry, go to the repositories and you see that repositories, click on repositories. And here you will see that one of them is the latest. These are the pushes, like it came here through that image post. Now we'll import and run the CD or continuous development pipeline. So let's go back to pipeline section. Select that new pipeline. Select Azure Repos Git here. Where is your code section? And select shop on web repository. And this is existing Azure pipeline YAML. And select the file and click on continue. So here we need to replace the value with our resource like actual values. So resource group in our case is just replacing those values. This is resource group. Location Southeast Asia. And subscription. So if you look here, you will see that it has got all the resources. So first it's download the resources like repository files that will be used in the task. And task is like Azure resource settings, and resource manager template deployment, which deploys the Azure App Service using that biceps template here. And then Azure Resource Manager template, another one deployment that add roles assignment using biceps. So now click on save and run. So it is just here just default message. You can modify based on your needs. Then click or meaningful message. Then select save and run. Creating pipeline. And here is the job. And different stage. It's queued status. Open into new there. And select the job itself. So pipeline needs permissions to access a resource before this run can continue to deploy. So select view and need some approval. So select permit. Again, this permit access. Now deployment is in progress. Let's come back when build complete. Deployment has been completed. Let's go back. Now, pipeline normally takes based on the project name. Let's rename this one. Identifying the pipeline for better naming. So let's click on rename and give this pipeline name. Click save. So build complete. Now if you go back the settings wise, if you see that the first one, that infra web app docker dot biceps, uh, this template creates an app service plan, a web app with system assigned managed identity enabled, and refers the Docker image pushed, which previously pushed that one. And the second one, that web app to is your role assignment. This template creates a new role assignment for the web app with arc pull role to be able to retrieve the Docker image. To see that one, let's go to the portal now. And if we go to the portal and select that resource group, and you see that this time and there are three resources like container registry on top of that app service and app service plan. So now select on the app service, and then here is the option select browse. You can also take the copy of URL and open a new page. So select browse tab, and you can see that the website. App service plan. So that is it for this lab. We can see that application is running fine. It's always better to clean up resources to avoid or incur cost. So it's recommended that you can clean up resource group and then clean up all the DevOps resources. If you have any questions, please put into comment. I'll respond as soon as possible. Mm, uh, Otherwise, see you in next lab. Thank you.